Yes, student, today we're going to solve one word problem based on quadratic polynomial. If the square difference of the zeros of quadratic polynomial fx equal to x square plus bx plus 45 is equal to 144, find the value of p. It is given that the quadratic polynomial is fx equal to x square plus bx plus 45. This is the quadratic polynomial. If we take the square of difference of the zeros, then it is equal to 144. So we don't know the zeros. Let the zero of this polynomial be alpha and beta. Let alpha and beta be its zeros. Since this is quadratic polynomial, so it has two zeros. Let it be alpha and beta. Now according to question, what we have, when we find the difference of these two and take the square of it, then it is equal to 144. Now let us do the basic calculation. We are identifying the relation a minus b whole square. So it will be a square plus b square minus 2 alpha into beta equal to 144. Now we have to solve it. So before solving it, we have learned the relation between the zeros and the coefficient, and that is number first, alpha plus beta equal to minus b by a and alpha into beta equal to c by a. In this relation we have alpha into beta, but in this relation we don't have the relation of alpha square plus beta square. So it means first of all we have to change this condition in the form of these two. So how it can be? What we will do, we will add and subtract this 2 alpha beta. We'll add 2 alpha beta and subtract 2 alpha beta in this condition only. See why we are doing it. This will be separate, minus 2 alpha beta equal to 144. Now by taking this, what we are observing, we have just added and subtracted minus 2 alpha and plus 2 alpha. But it remains the same, alpha square plus beta square, as both of them will be cancelled and we are getting the same condition, alpha square plus beta square. But for changing it in the form of alpha plus beta or alpha into beta, we have to do it. So if we will take these three terms, alpha square plus beta square plus 2 alpha beta, this will give a relation a square plus b square plus 2ab equal to a plus b whole square. It means we will get alpha plus beta whole square by taking these three. So now what we are observing, that we have alpha sum of zeros, we have product of zeros. Now this condition has been changed into sum of and product of zeros. So some basic calculation will go to do. First of all, this will give alpha plus beta whole square, minus minus will be give minus 4 alpha beta equal to 144. Now the quadratic polynomial, we have x square plus bx plus 45. From this, let us find the value of alpha plus beta, which is equal to minus b by a. Now in place of b means coefficient of x, we have p. So it will be minus p by, in place of a means coefficient of x, we have 1. So in place of alpha plus beta, we have to write minus p by 1. No need to write 1, we can write only minus p. So here we can write minus p whole square in place of alpha plus beta. Now next, product of zeros means alpha into beta is equal to c by a. The value of c we have 45 and the value of a we have 1. So in place of alpha into beta we can write 45 only. Now do the basic calculation. Minus square will change into positive, so it will be p square. 4 5 20 0 2 4 17 18 180 144. Transpose it to the another side. This will give 144 plus 180 and this will change into 324 p square. When we take the square of a square to the another side, it is changed into square root. Now one more point we have to note down. Whenever we have to find the value of any missing number, with the square root we have to take the positive and negative sign also, because it will give two values. Both the values are valid for it. So Now we can easily observe that 325 is the square root of which number? It is of 18. So the value of p will be either plus 18 or minus 18. Now let us move to the second. So this way we can calculate it. Let us move to the second word problem. One more word problem we are taking. The second word problem says if the sum of the zeros of the polynomial is equal to their product, find the value of k. Here we have the polynomial ft equal to kt square plus 2t plus 3k. Sum of the zeros is equal to their product. We don't know its zeros. Let its zeros be alpha and beta. Let alpha and beta be its zeros. Then according to question we have sum of zeros means alpha plus beta is equal to their product means alpha into beta. Now from this we know that sum of zeros is equal to minus b by a. In place of b means coefficient of t, so it will be minus 2 upon, in place of a we will write coefficient of t square, it is k. So in place of alpha plus beta we can write minus 2 by k, and alpha into beta we know it is c by a. The value of c we have 3k and the value of a we have again k. So in place of alpha beta we can write 3k upon k. So by doing the basic calculation we will get k and k will be cancelled. This will give minus 2 by k equal to 3. We have to find the value of k. Let us interchange the places. Minus 2 by 3 equal to k. So this implied that the value of k over here is minus 2 by 3. So this way we can solve the problem based on zeros of quadratic polynomial. Thank you.